Hey girls, today we're going to be learning about quadratic relationships, which we know from our polynomials chapter means that this is going to be degree 2 or the power of 2. And this is the first thing that we're going to learn about is just graphing them and analyzing what their graph looks like. So first things first, let's take a look at the parent function. You guys already know a few parent functions. You know the linear parent function, y equals x to the first power. It makes a straight line. And you also know the parent function that's absolute value. It's y equals the absolute value of x, and you know that graph makes a V shape. In addition, you've now learned the exponential parent function, y equals some base to the power of x, and you learn that that makes kind of a J-shaped curve. And in this chapter, we're learning more about y equals x to the second power. In standard form, the equation is going to be y equals ax squared plus bx plus c, but a can't equal 0 because then you wouldn't have x to the second power. So it's similar to the linear standard form, where in standard form for a linear, it was ax plus by equals c. This one's just, it's a power of 2, so that's why it's ax squared plus bx plus c, and that's equal to y. The shape of any quadratic function is always going to be a U shape, which is known as a parabola. It can open upward or downward. It opens upward and it has a minimum value if the a value is greater than 0, or in other words, if it's positive. So if this first number here, the leading coefficient, is positive, then that means it's going to open up, a normal U. But it's going to open downward and have a maximum value if the a value is less than 0, or in other words, if that a value or leading coefficient is positive. So you'll notice this shape that opens up, minimum, the shape that opens down has a maximum. There's a special name for this line that cuts the parabola in half. It's called the axis of symmetry. And in order to find the axis of symmetry, you can follow this equation, x equals negative b over 2 times a. You'll have to have that equation memorized, so start learning it now. It's x equals because it's a vertical line. Way earlier on this year, we learned that anytime you have a vertical line, it's x equals a number. So you'll plug in b and a from standard form and simplify it, and you'll understand that it's x equals a number. Whatever you get for the axis of symmetry, that's going to be the same as the x value for the vertex. The vertex is just the special name for that maximum or minimum point. We also saw a vertex when we saw absolute value. It was the same thing, the maximum or minimum point at the top or bottom, like the pointy part of the V shape. This is just the top or bottom of the U shape. So when you want to find that point for the vertex, the x value, you use that formula, negative b over 2 times a. So that's your x value. And then to find the y value, you're going to plug it back into the equation. So you can write it as f of negative b over 2a. That's just saying you plug negative b over 2a back into the function. The x-intercept, it's helpful to remember that it's always just equal to the c value. Because think about this, remember the y-intercept is always where the x value is 0. So if you were to take your standard form and you plug in 0 for x, that means that this would all equal 0. So it would basically just go away because adding 0 doesn't change anything. Same for the linear term. The linear term would also end up just going away because anything times 0 is going to make 0. And you would end up with just the c value. So what that tells us is that the y-intercept is always equal to the c value when it's in standard form. The domain, similar to most of our functions that we've talked about this year, is all real numbers, or you could write it with that special r, or you could write it negative infinity to positive infinity if you wanted to put interval notation. For the range, it's a little different. You could either say y is less than or equal to the max or y is greater than or equal to the min, depending on whether it faces up or down. If you want to put it in interval notation, you're going to go negative infinity, comma, the max with a bracket, or you're going to go bracket minimum, comma, infinity. That max and min that you're filling in here comes from the y value of the vertex. Because if you remember, the vertex is the highest or lowest point on the graph, so that's going to tell you the highest up that the graph goes or the lowest down that the graph goes. And remember, for range, you're always using a y value, so that's why you're plugging in that max or min, the y value of the function. In order to start understanding these a little more, we're going to look at graphs first, and we're just going to identify these characteristics from the graph. So the instructions say to find the vertex, the equation for the axis of symmetry, the y-intercept, and the zeros of each graph. State the domain and range. As a reminder, zeros is a special word for x-intercepts, and just to let you know, a parabola, or remember that's what this shape is called, a quadratic, it can have either 0, 1, or 2 x-intercepts. So let's take a look at our first example here. We'll start just in order, find the vertex. So the vertex is the highest or lowest point. In this graph, here is the vertex. This is the lowest point. Let's determine the scale of our x-axis. It's counting by a half for each little line here. So we know that this is an x value of 1. And since it's on the x-axis, it's a y value of 0. So the vertex is that point here, 1, 0. Next it says find the equation for the axis of symmetry. The axis of symmetry is the vertical line that cuts the parabola in half. Remember, the equation for a vertical line is always x equals. This vertical line has an x-intercept of 1. So the equation for this axis of symmetry is going to be x equals 1. Remember, the equation for the axis of symmetry, that x value will always match the x value of the vertex. Next, the y-intercept is where the graph crosses the y-axis. Here's the y-intercept for this graph. Determine what's the scale on the y-axis. It's also counting by a half, meaning that this is a y value of 1. So the y-intercept is going to go 0, 1, because its x is 0, its y is 1. For the y-intercept, the x value will always be 0. The y value is where it crosses the y-axis. Next, what are the zeros of this graph, or in other words, the x-intercept? This parabola only has one x-intercept. It happens to be the vertex. So this one is also the 0 is 1, 0. The 0 or the x-intercept will always have a 0 for the y value. Finally, we have to state the domain and the range. Remember, the domain will always be the same answer, negative infinity to positive infinity. This is always the domain for every parabola or every quadratic function. The range is a little trickier though. The range you have to either look from the minimum up to infinity or the maximum and it's down to negative infinity. This one, it's opening upward. So if I wanted to shade this in, what are all the values covered? I would have to go off the graph at the top. For my range, it's starting out, the lowest that the graph goes is this y value of 0. So I'll put a bracket with a 0. That's the lowest y value. And the highest y value is infinity because it goes off the graph at the top. You'll always put a parenthesis by the infinity or the negative infinity. Let's do another example together. This graph has a vertex here. It's 0, negative 4. The scale on my y-axis is counting by 1s, meaning that that's -4 here. Now, let's figure out what is the equation for the axis of symmetry. It's going right through the y-axis. My axis of symmetry is x equals 0. My y-intercept here actually happens to also be my vertex, because that's where it hits the y-axis. My zeros, this parabola has 2. I have a 0 here. The scale for my x-axis is counting by 1s. So this is the 0 is at 2, 0. And I have another 0 at -2, 0. Notice the axis of symmetry is making it symmetric on each side. So that's why these end up at +2 and at -2, because it has to be equal on both sides of the vertex. Finally, the domain is all real numbers. We said that's always the answer. And the range for this one, the lowest to the highest, look like this. That's a low value of -4 and a high value of infinity. Remember, you always use your y values for your range. A bracket around the number, a parenthesis around the infinity. Okay, pause it and try the next 2 examples on your own, and I'll give you the correct answers here. Here's that. Tomorrow when we come back, we are going to be working on graphing these on our own. So based on the equation, we are going to be taking the equation and making the graph ourselves now. So be ready for that. Make sure you study your formulas. You're going to have to know those. Study your domain and range. And I'll see you guys tomorrow. Bye.